Okay.
What are we at
Now.
now? Hi, I'm Karen with the Gaithersburg Community Museum, and thank you for joining us for our Perseverance Celebration. Before we start with tonight's talk, I want to give a shout out to our partners in creating this two-day Perseverance extravaganza, the Rockville Science Center. They hosted a fantastic talk last night with Eric Wellness on the Perseverance technology and a watch party this afternoon. We have a lot of great programs coming up, and I encourage you all to go to their website, rockvillesciencecenter.org, so you can see all the different things that they're doing. Not all about space, they do all of science, so should be a lot there for you. Also wanted to give you a heads up that our Storytime station on Tuesday is all about saving our world with author Mary Boone, because, you know, we like to think big at the Gaithersburg Community Museum. So we recommend this really for ages 5 and up, or even a little younger. If your kids are really into saving the world, well, this is the program for them. And you can, so that's 11 o'clock in the morning this coming Tuesday. So I want to introduce our speaker, our presenter tonight. Becky Lawrence is, she has aerospace welding, and she does welding for NASA and other aerospace companies. And she's a Gaithersburg High School graduate, class of 1972. So any of you GHS people out there, welcome, Becky.
Oh, hello.
Hi. Thanks for joining us. Yes. Becky also, I should tell everybody, teaches welding at Frederick Community College, and she also does some advanced classes for Montgomery College. So some of you may have even had classes with her if you've done welding as well. So tonight's program, Becky, I think it's going to be more like a conversation between the two of us. And I know we have some photos from you to share, but for the audience out there, I really encourage you, if you have any questions for Becky, please put them in the comment section and we're happy to ask her. This is really, as I said, a conversation, not quite a presentation as they usually are. So you ready to go? Are you ready for your first question?
I'm ready.
Okay. So I guess one of the reasons that I reached out to you to do a program is I was curious about how welding something that has to go into space might be different from welding, you know, something on your car, say. What is the difference in technology or skills or?
Well, mostly it's cleanliness. You know, you have to keep everything clean, and a lot of times they want to have, if it's something, I do a lot of things for welding for high altitude balloon projects, and not a whole lot of stuff. I'm a contractor, so I don't work at NASA or anything. I just, so they have me do the preliminary stuff, the ground stuff mostly. Sometimes I do stuff that goes up, like payloads for high altitude balloon projects and satellites sometimes. But a lot of times there was a time that I did some fuel line work for the International Space Station. And those parts, they had 3 engineers come to my shop, and at every little tack that I tacked, and every weld that it was in sequence, and I had a big 3-ring binder, and I had to sign off on every single part, and they had to sign off, and someone had to actually be in the shop with a helmet and witness it. It was a little nerve-wracking.
I can imagine. Boy, talk about the paperwork. That sounds crazy.
Yeah, and I had to do it weld the parts in triplicate too, so that, and they were all bagged up and labeled and but I don't know, because they would test them, of course,
Mhm.
so that's why.
Okay. So what kinds of welding processes do you use? And if you can talk a little bit about, how one is different from another.
Sure. So there's many different welding processes where you're joining metals together, or you can even do plastic welding. Doesn't have to be metal, but um, there's gas welding with oxygen and acetylene, and it's oxygen, OAW, oxygen acetylene welding. You can weld with gas, and you don't need electricity. Or you can do, there's laser welding. I don't do that, but there's spot welding done with a resistance welder. There's most people think of it as stick welding, where you have a consumable electrode. So that's now called SMAW, shielded metal arc welding. And you have to use the proper terminology. I'm chairman of the American Welding Society for the area, DC, Virginia, Northern Virginia, and Maryland. And in the American Welding, I've been a member and on the executive committee since like 1988. But you have to use a proper terminology. So there's stick welding. There's what I mostly do for these NASA projects and for these scientific apparatus that I make is GTAW, commonly known as TIG welding, gas tungsten arc welding, and that's with a non-consumable tungsten electrode, and you fuse the pieces together and you hold the filler rod in your other hand and you feed it your torch, your filler rod, and you have a foot pedal, rheostat pedal that you operate with your one of your feet. And if you're doing a rotating, then you got all four of your appendages working. If you had a rotator, you're operating with another rheostat foot pedal for the chuck on that. So all four are, it's like rubbing your tummy and patting your head. And so, and then there's also MIG welding, which is gas metal arc welding. And that's you have a MIG gun, and it's a consumable wire that strikes the arc that has the, and then that arc consumes the metal and you fuse it to the metals together like that. So there's many processes, and there's plasma welding, and I've done that. So mostly I do TIG welding or stick welding, or depends on what I'm doing, really.
Okay. Can you talk just a little bit about what metals that you use, or what can you use together, what can't be used?
Sure. So I mostly, most of the things that I weld for different people, like I do work for Johns Hopkins. I do work for University of Maryland, because I used to work there in the physics department. And I do work for NASA Goddard. And I mostly work with stainless steel, and I weld most of these apparatuses with stainless steel I use. So you can weld stainless steel to steel, but it's not, but you have to use a certain filler material, and it's a 309L, which means low carbon, instead of like a 308 that we would use for stainless steel. You have to be aware of what filler materials to use for what metals. You have different types of aluminums that you're using. You can't weld aluminum to stainless steel. You can weld different stainlesses together. But you can, I have welded Inconel, which is a nickel alloy, chromoly, which is a lighter weight steel, high chromium steel. That's on a lot of airplane.
Mhm.
They use that, and on car roll cages and stuff. And titanium, of course. So I'm certified. I've got hold certifications in aerospace welding for the American Welding Society, in titanium, stainless steel, aluminum, steel, structural steel, for the steel, all positions and unlimited thicknesses. I have a chromoly certification and Inconel certifications. So whenever I need to be certified for something else, then I'll go ahead and get that certification.
Okay. And just one more little technical thing is if you could just talk briefly about the difference between soldering and brazing.
Yes, I do have to do a lot of that. Oftentimes somebody will want some copper or brass pieces soldered or brazed to stainless pieces. And in that case, you can't weld them together. You can't weld because copper melts at such a lower temperature than steel or stainless. So that you braze it. Now it's a process wherein you're not melting the base or parent metal. You're you're getting it hot enough, and you're using a flux to precipitate that adhering. And so brazing is I do silver brazing on most of these scientific apparatuses. So I'll use a 45% silver, and it melts at about 1400 F. And so anything that's silver brazing, and anything above 840 degrees Fahrenheit is brazing, and below 840 degrees Fahrenheit is soldering. It's that simple.
Oh,
So soldering is a lower melting process.
okay. All right. Right. How, can you talk a little bit about some of the projects that you've participated in or done or built? And I
Been
usually
welding for a long time. So I just finished, I've done a lot of work for Hermes, HIRMES, and Hermes 2, and those were high altitude balloon projects. I did the landing gear cart that for that, and I built that. So let's see what other. So
is this a good time to show some of those pictures that you?
Sure. I just finished something. Some little. I should. I'm not sure I'm supposed to show you those pictures. I didn't send them. It's called CADMES Cadmus, and it's like I've done some work for the Dragonfly mission to Mars, and so Cadmus is similar, but it's going to Jupiter, to Europa. Yeah, Jupiter's moon Europa. So so I did some little parts that have been laser drilled with so there's a sieve in them after I welded them, and they're just like little teensy parts, 3/4 of an inch by an inch, and what they are is to hold sediment that the robot, similar to the rover, it scoops up and puts through the sieve, and then that is put into the mass spectrometer of the mobile lab there. That then robot will see, they smell it sort of with the mass spec, and see what we have scooped up there. So that's Dragonfly, Hermes, Da Vinci Plus. That's the one I've done some titanium chambers for that project. That's going to the Venus atmosphere, and I recently did a big stainless steel stand a channel stand for that. Um, let's see, X Badger radar. Um, I've done some stuff at NIST.
Why don't we pull up those pictures that might, might be
Right.
interesting for people to see?
Okay, all right.
Hopefully, there we go.
Okay, okay, that's a bellows. That bellows is 6,000 thick. It allows those, there's some flexibility in those, and I welded that to those flanges. That's for the University of Maryland Gravity Project. Oh no. So you can just keep flipping through and I'll go through it. Yeah, that's the same. There's, oh, that's that's a fun thing I was working on. That's the starting of this helicopter project I was doing with a friend of mine who Howard Connolly. He's an artist, and that was going into Andrews Air Force Base, I think, into their one of their big buildings. So that you can keep scrolling. That was a big aluminum helicopter. That's a this is an aluminum box. That's my shop. That was a toolbox going to go on a ship off the coast of Africa to hold the diving, the welders that were diving down to repair a large pipe that's on the floor of the ocean off the coast of Africa. So that was holding all their equipment on shipboard. Okay.
Wow. I guess that must also be special.
This is aluminum, and I'm the same thing. I'm welding on that. That's me. And see, I'm holding the TIG rod, the filler rod, which is aluminum, in one hand as I'm welding with the other hand.
So the TIG rod, is that thin?
Yes.
That thin line that I see in the photo?
Yes, that's the filler material. It's a so there's different alloys that you want to use for different things. So that was welding in there. And again, welding on the aluminum box. You have to get into all these different positions, under things and on things and over things, and it's challenging at times.
Mm-hmm.
Now that's the finished frame that we will yeah.
That's in your shop, right?
Yeah. Yes, it is. Yes. That was a cryogenic aluminum cryogen vessel that I was welding some ports into in the bottom of that vessel. You can see one of them I had already done on the right hand side, on the right behind my elbow, and I was welding another one, and my feet were sticking out, and I was operating the rheostat foot pedal with my foot at the same time as I was welding in this closed vessel down there. But to not be careful and do it a little bit at a time so you don't run out of air, of course. So
yeah, I guess
that was for NASA, for one of the codes there.
Okay.
So these are dilution refrigerators. They're about 4 inches. That's a very small dilution refrigerator for let's see, about 4 inches by 6 inches, 8 inches maybe. So this is copper, brass, and that tubing that you see there, the tiny one, that's 1/4 inch diameter, but it is 5 thousandths wall thickness. They wanted it very thin, and that is about as thick as a piece of paper. And so that is welded to another flange, and then a lot of it is brazed, and that was a difficult job to do. As you can see a brazed joint and by somewhere. Yeah.
Mhm.
Stainless steel, brass, copper. And there's a tiny little copper tube that comes out of it where they would do the vacuum, run the vacuum on it.
Okay.
It's got liquid helium in it. That's to keep it very cold.
Okay.
That's in my shop. Now that on the table, on my welding table is that's the stand for the Da Vinci plus Venus Atmosphere project. And stainless, they wanted it very, very flat because they couldn't machine it after I welded it. So I used a lot of clamps on that. I clamped it and it stayed pretty flat. I just clamped it, and anywhere I had to weld it, I'd take the clamp off and then put it back on and worked my way. I welded it here and then across, just to dissipate the heat so it wouldn't warp.
Wow, it looks really involved.
Yeah. Those are copper heat straps for a different code group in NASA. These are high power electric copper braid. Those braids are about 1/4 inch in diameter, and they wanted it welded, not brazed. So that is copper welding, which I did with a lot of argon, and it heats up and dissipates really fast. So it takes a while to get up to heat, and then it'll go fast. So you've got to sit on it with your arc, and then as soon as it starts melting, then you have to move real fast.
Okay.
So this is my setup for, this is a cryogen vessel flange for a different code over at NASA Goddard. I was repairing, they had bought this and someone shipped it, and it was cracked, and I had to repair that. And the tubing coming through was a lot thicker than the flange. So I had to put up some copper heat sinks all around it. And I had to use a lot of argon too. Argon to shield the metal, because if you don't shield it with argon, it'll get oxidized and contaminate, and then it will crack.
So I do have a question. I think that this is a good time to ask it. So the ask again is soldering a different process. So
Yes.
as opposed to TIG, soldering would be.
Yeah. So TIG, gas tungsten arc welding, is an electric arc process, welding process. And that's welding where you're welding two pieces of metal together. But soldering is not melting the parent metal, and you're using a heat source. You can TIG braze, but you can use a silicone bronze to TIG braze. But however, usually they just use a torch. You use an oxyacetylene torch or a propane torch, something to melt that solder, get the metals hot, the copper, the whatever hot, and melt that solder with a flux to join those metals. You're not actually making a metallurgical change, a diffusion in the metals. You're not actually melting those together. You're fusing them with a third metal, which is the solder.
In the aerospace worlds, can you weld dissimilar metals together? So a couple of the things you've showed us have been mixed metals.
Yes. Some of those were brazed, like copper to stainless. You would have to braze or solder. And
are there any metals that absolutely cannot go together?
Sure. Aluminum and stainless. So yeah, or titanium and steel, most of those there. See, the coefficient of expansion is different. It's metallurgically, it's just too different. to weld. You can, like I said, you can weld steel to stainless steel, but you have to use a certain type of filler.
Okay. So let's, we can continue on with the slides. I don't know where we are in them.
Well, that's that same after I finished it, after I finished that joint. There it is, the top of it there.
So what are so
those are what this is a cryogenic vessel flange. They put that, it's upside down there. So
okay.
Top the flange, and then they will draw a vacuum through those flanges.
It's pretty awesome looking, actually.
That is a cryogenic vessel that I was making for NASA for
Okay.
stainless steel.
Okay.
So when you're, okay, that is stainless steel. I was doing that for a group at the University of Maryland. And that was thin wall stainless steel tubing to a fitting, and then it was welded to those that oblong flange over there.
All right.
Yeah, there's the weld that is, and there's the tubing you can see coming out the back end of it. And you can see the tungsten there to the right, the picture where the I have a Pyrex cup on my torch.
Oh,
and
yeah.
That is a tungsten electrode where the arc is initiated onto the metal. And then of course you've got a ground clamp. So that's what's making that connection, you know, for the electric arc to goes through from the tungsten electrode through the material onto the table and the ground clamp.
Okay.
That's a stainless steel part that I had just welded. It's oxidized and I had not cleaned it up yet. I just thought it was pretty. And that was for someone at NASA, and I can't remember who. So these are, you can't tell, but in the back of those are glass. That is a glass to stainless transition. I did not do that. A glass blower did. So these are bellows, 6,000 wall bellows that I had to weld to a tube, to a fitting. And that's a VCR vacuum fitting. So I have this same job every couple months for this guy who has Opthos Instruments up in Urbana.
So you created the metal piece and then the glass blower put the glass on it?
Yes, yes. Well, the bellows is made, you know, at a scientific, at a factory, they make bellows, and then I weld the bellows to the fitting, the swage lock fitting, and the glass blower has already done that housekeeper seal to the glass to the stainless steel.
All right.
Yeah, that's the same. You can't see the glass. It doesn't look like glass in that picture.
No, it looks all like metal.
It's funny. Okay, so this is a vessel that I was modifying for another company up in Gaithersburg. Zero nanotech. So that's doing that. There's going to be a laser in there. Yeah. There is my shop. So I was putting argon. This is argon back up into this. This is an interesting job. About a year ago, I think. not even a year ago. So I got a call at 7:30 at night, and I answered the phone, and I don't know why, to my business, and I said, aerospace weld. And this guy had a thick accent, and he said, can you weld stainless steel? I said, yes. And he goes, well, I need a job done tonight. And I said, tonight? I'm closed. And he said, well, no, we'll pay you. We'll pay you. Can you come to the airport, to Dulles Airport? And I said, well, okay. And he said, well, we'll give you $500 extra just to come to the airport and pull this. I said, what exactly is it? They said, well, it's part of the airplane, a Ukrainian jet for some Ukrainian airplane that was going to fly somebody from the State Department to Kiev, and they had to fly out, and so we were trying to get this all set up for in the middle of the night. And I said, okay, I'll meet you at my shop with the part because I can't do it at the airport. And they're like, oh, okay. Then I go, there's like 10 Ukrainians, can't speak English. And I had to call a guy in New York somewhere and have him translate. And they all came to the shop, and I had to weld this in the middle of the night. And it was really crazy.
That's quite a story. You can just see the movie of it happening.
Yeah.
And it does make you think you don't want to fly Ukrainian Airways.
Yeah. Well, it's crazy that, they said, well, no, we have to fly out. We have to, I'm like, okay. Oh, and they had, I shouldn't maybe say this. They had some tanks in the airplane.
Okie dokie then. There's definitely a story in there.
Yeah. Yeah, that's the part there that I fixed. It was cracked, like it was. Oh, this whole part on the left there had been torn away from it, and I had to weld it back on.
I hope the plane made it. I'm sure your work was fine.
Yeah. That's weird, really strange.
Okay. I just see it a little more closely.
Yeah.
All right. Well, you were also telling me about some job that you were basically working on the same thing, but for.
Yeah. So actually, it was they were had their designs for a comet that was passing by recently, and this was a couple of years ago, that I had to, and I was doing the work for 3 different groups at NASA, and I had to, they were like, I hear you're working for so-and-so, what are they doing? I'm like, I can't tell you, and so a couple of them were titanium, and they had different ideas of how to collect some sediment off the surface of the comet, and like some of them were like arrows almost that they went down and grabbed it, and then they tethered back and to the satellite and stuff like that. And so they had, I was working on 3 different projects for 3 different groups for the same thing, and I don't know who finally got the bid, but somebody.
So, talking again, just sort of about the unique challenges building for space might have. From the Rockville Science Center, they ask, so talking about, being in space. On Mars, the temperature ranges from -22 to 70 degrees. How do most welds behave with such a wide temperature range?
Well, you know, titanium, uh, metal is very forgiving. You can take metal down to cryogenic temperatures, you know, and the welds, I've done many aluminum and stainless, although most things that are going to Mars are going to be stainless or titanium. And and those temperature ranges are perfectly acceptable for a good, you know, a good clean TIG weld. Is now sometimes if things are done, a weld is done autogenously, which means without the filler material, just fused together. It's an autogenous weld. It's not quite as strong, and they use those welds for vacuum vessels mostly, but they're very strong. The metal is if you a good certified weld is stronger than the metal that's connecting to it. So if you're, and these are over designed, you know, by many times, and so it's not going to break in the weld zone. It's been tested, and they test them, and that's what they're doing over at NASA. They're testing. They design these parts. You know, they have somebody machine the parts. They have somebody weld the parts. They go through different, you know, ideations. And then they try them. They test them. They test them at cryogenic temperatures. They test them at high temperatures, and they cycle them. So everything is done ahead of time. They do their homework.
Okay. All right. So I want to just talk a little bit about you, a little less about the welding. So we actually shared this event with the local Girl Scout troop. So I do want to say, if there's anybody out there who's part of Girl Scout troop and you want us to give you a shout out, please put your troop in the comments. But so, well, it's no surprise to you, Becky, that there aren't very many women who do welding, let alone women who weld at the level that you're welding. How did you end up choosing this as your career? How did that come about?
Well, when I was about 13 or 14 years old, and my dad was a physics teacher for Montgomery County Schools, and we lived on a little farm up near Clarksburg, Boyd's, and he would go to farm auctions, and one time he came back with a little Lincoln tombstone looking, that's what they call them, welder, an AC welder, and I was very interested in that. And then I was and didn't like to be inside. I'd like to be out in the garage or in the barn, or, you know. Anyway, so he got an oxyacetylene torch also. And there was no YouTube back then, and I didn't know what I was doing. It was probably not smart of my dad to let me play around with it, but he did. And so I was excited to go to Gaithersburg High School, because I knew that I was at Gaithersburg Junior High, and then I went to Gaithersburg High, and they had a welding program I was very excited about. And they told me when I went to Gaithersburg High School in 1969 that I could not take welding, and I also wanted to take woodworking, that I had to take home ec and child development. And I said, no, I'm not. I don't want to. I'll take that. So I passed around petitions and got a lot of my teachers signed these petitions, and had a little sit down strike and outside the vice principal's office, Mr. Crabtree. And, and so I got to be one of the first girls, I think probably in Montgomery County, to be in a welding program at a high school. And by the time I was in the 12th grade, I was in the welding shop or the art shop or the art room half the day, because I knocked out all my prereqs, and I liked welding a whole lot. And I started making metal sculptures, and didn't really get a job as a welder for a while, about 10 years. But I thought I could make sculptures and sell them. That didn't go too well. So they were heavy to truck around to places. But
I can imagine.
I eventually went back to school and got a 2-year degree in advanced welding technology. And that they had that I think in the mid 80s at Northern Virginia Community College. I went there. And then I got a job at several different shops in the area, just MIG welding and building horse trailers and stuff, and trailer hitches. And then I eventually got a job at the University of Maryland Physics Department as their technical welder. And that was great. And I learned a lot. I learned how to do vacuum welds and titanium and all the fun stuff. And then I went over to NASA Goddard and trained and certified in aerospace welding, so that I could weld on contracts that the University of Maryland would get in as they worked with NASA for these different projects. I know I've worked on a lot of high altitude balloon projects, also with Catholic University and NASA. And and I did do some work on the electronic beam accelerator at the IREAP Applied Physics Lab at the University of Maryland. I welded a lot of that. That was a lot of fun. But I brought these. I had my students weld razor blades together on their last day of TIG class. I don't know if you'll be able to see these, but so this is razor blades, and these are box cutter blades, and here's razor blades that I have my students do this on the last day of class. I'm like, okay, you got to do this. And then also, of course, I have them weld together aluminum foil and make little bags. And I tell them that they can't graduate from my classes unless their little aluminum foil bags hold water. And of course they can, but I just tell them that. But that's a fun thing for them. It's, it's a fun thing for them to do. So I really miss teaching this past year. I do teach online a blueprint reading class, but it's just not the same.
Yeah, not the technical stuff that you can't get on.
Yeah, right.
Virtual.
Yeah.
That does strike me as challenging. But somebody asked, I think we may have a future welder out there. If your company ever takes interns.
It's just me doing the work. So I'm just a small company, and I'm all, that enables me to just pick and choose, but my jobs, I don't really take interns, but I would be happy. Hopefully we'll get up and running here in the summertime. At Frederick Community College Monroe Center, and I teach intro and advanced welding there. I teach at the Montgomery College Godulski Center. And anybody would be welcome to take classes there. And we do. It is a lot of fun, and welding is just so much fun. And I don't think I'll ever stop welding because I just love it. I like the tiny parts, like this little, this is a 20 thousandths small quarter-inch tube welded to a 1/32 inch tube that's a larger diameter. Let's see, can you see the weld? I don't know if you can see the weld or not.
It's very...
Yeah, so yeah, okay, it's tiny. But I like doing little tiny things, Oh, I know what, can I show you the cold trap that I made for Johns Hopkins?
Sure.
So I haven't delivered this. I was going to deliver it today, but so this, I sent some pictures too of this as I was assembling and putting this together. So let me take these. I should have had this tape off of here. I taped these to protect them. This is, so what it is 2 1/4-inch tubes welded into the body of the cold trap. Now inside this body is, this is a 1 1/4-inch stainless steel tubing, and that's the weld on the top. And these tubings, 1/4-inch tubings, are welded on the inside of this lid here that I welded. Now inside of here, there's charcoal up to here, and it cycles gases through here, and this is immersed into a dewar full of liquid nitrogen. That's why they call it a cold trap. And so then the bottom is welded here. And so then the bottom of these inside of here, before I put this all together, I had to weld screens onto the bottom of the tubes, tiny screens onto the bottom of the tubes to keep of course, the charcoal from going up inside.
Oh, yeah.
Yeah. So these fittings, again, these are swage lock fittings welded onto the tubes. This one's got tape on it. And this is called a male nut, black nut right here. Anyway, this is the kind of stuff I like to do. It's lots of fun. So
That's look like fun. So I think we're kind of coming to the end of our questions. It's the last call for questions if anybody has anything. This has certainly been quite fascinating. And I hope there are some girls out there who've been watching who get a little inspiration.
I hope so too. I always, I do have female students every once in a while, maybe once a year. And I had a student a couple of years ago at Frederick, and she was a really good TIG welder, and she got a job, but now she went into something else now. So I mean, there's not a whole lot of I'm a member of several Facebook groups, women welders. There's a lot of women like working on pipelines now in the West, and that's really good money if you're young and hardy.
Yeah, I can imagine. I mean, being at these meetings and going to things, and there just aren't many women there. And
there are not a lot of women.
I know that's always disappointing.
It is. I mean, because women make great TIG welders. I mean, because it takes a lot of patience. You can't rush it. You've got to have very good eye-hand coordination, and you've got to do different things with your hands and your feet, at different times, and you've got to watch this and that. And so you've really got to be a good multitasker, which I'm not in real life, but in this world.
Well, I want to give a shout out to Matina Banks, who says that you have inspired her tonight. So perhaps when we're all back in-person classes, Matina will be in one of yours.
That would be lovely. That'd be really awesome. And really, we certify too, so you can get your certification. We're setting it up for Montgomery College, but we've been doing it for years at Frederick Community College. Get your, it's for SMAW stick welding, structural, it's called the D1.1 code.
Very technical.
I'm all about that code. I'm all about being having my welding codes and welding certifications. That's what makes you good,
Yeah.
So,
Details are
right.
important. Well, Thank you so much for joining us, and I hope
My
our
pleasure.
audience out there also enjoyed it. And just again, I want to shout out to the Rockville Science Center. It's always fun for us to put these programs together and work together. So it was really great. And I encourage everybody to go to their website to see all the programs they have coming up, rockvillesciencecenter.org. And a reminder again that on Tuesday, our Storytime Station is all about how you can save our planet. And if that's not a topic that
What?
begs to be listened to, I don't know what is. And for all of you who are really into astronomy, I just wanted to tell you that the event hasn't been posted yet, but we've just arranged with Dr. Jim Bell. On April 16th, he's going to give a talk on the ultimate tourist guide to the universe. This is really entertaining as well as instructive. And I hope you'll all keep an eye out for that. And I hope you can join us then. So until next time, thank you. Thank you for joining us. We'll see you again.
Very good. Thank you for having me.